Yo, I know. Game development feels huge. Graphics, physics, AI, story, etc. But every game, from Pong to upcoming GTA 6, is built on a handful of core concepts. Let's run through all of them in just 20 minutes. Every journey starts with a foundation. For us, it's the game engine. Think of it as your toolbox and workshop rolled into one. It takes care of the heavy lifting such as graphics, physics, input, and more, so you can focus on actually building the game instead of reinventing the wheel every time. Unity, Unreal Engine, and Godot are the best examples of this. Now, before any art is drawn or code is written, pre-production is where you sketch the vision. It's the phase where you figure out what the game should be, the concept, the scope, the feel. And once the concept feels real, you dive into actual game designing. Here, you're not just deciding rules, you're writing the laws of physics for your universe. How does the player move? What challenges block their path? So, to craft the rules and systems that make your game actually fun. After that, we go to world building, the part where everything starts to feel alive. You're not just painting backdrops, you're sculpting a place that players will breathe in. The culture, the logic, even the stuff you never explain. It all matters. Because if your world feels shallow, the game dies no matter how slick the mechanics are. Minecraft is the best example of this. I think I don't have to explain this part since you all know from here. And after creating your first game project, you prototype. This is your first date with your idea. You smash together the bare minimum, just enough buttons, boxes, and placeholder art to see if it sparks. This is done in 3 steps, to be honest: playtesting, bug testing, and feedback loop. Playtesting is that phase where you put the game in front of players as early as possible and ask the big questions. Is it fun for 5 minutes? For $30? Is it fair for everyone? Once the core experience feels right, you move on to bug testing to catch crashes and technical issues. Finally, you close the loop by gathering feedback from testers, using their insights to refine the design. Following this cycle ensures your prototype is both playable and worth building on. But games aren't born perfect. They're made into one. The iteration cycle is that endless loop of test, tweak, repeat until the game feels right and you stop hating your own build for 5 minutes. You can also call this as an endless loop of prototyping. And while all that's happening, there's the part no one brags about: asset management. Keeping your art, sounds, and scripts organized is like cleaning your workshop. Ignore it, and one day you'll open a folder that looks like a digital junkyard. And trust me, that can kill projects faster than a bug. But no matter how well you build it, your game will break. It's part of the process. Okay, your next line will be, "That's why bug testing exists, right?" Well, it does not magically solve the bugs. It only finds it. The process of fixing them is called debugging. Whether it's a crash, a character stuck in a wall, or a score counter that refuses to update, it quickly solves the issue by finding the root cause. It may not be quick, because you will soon realize that it's not optional. It is the daily grind that keeps your project alive and moving forward. All right, up to here. Everything is a GarageBand stage.
目覚めたまえ、我が主たちよ。
Once your game has a foundation, you need the things players actually see and touch. That is what HUD does. The health bar, ammo count, minimap, all the stuff that keeps players alive without pausing. In fact, HUD stands for heads-on display, so you can understand that it's the thing the user sees on the screen, except the player. Add little flair like status effects popping up, poisoned, slowed, shielded, so players always know what's really going on. But survival isn't enough. Players need a backpack, and that's your inventory. More than just item slots, it's where the player feels their progress. Every sword, potion, and scrap of junk tells a story. From there, you give players direction through a quest log. Think of it as the game's to-do list, but with a sense of adventure. It keeps players from getting lost and remind them what they're chasing. A nice touch is letting players choose which quests to track front and center. No one likes cluttered lists. I know the explanation may be confusing. Take Cooking Fever, for example. The quest log tells you which orders need to be completed, which recipes to unlock next, or which restaurant upgrades you should focus on. You can see serve 10 burgers or upgrade the fryer right at the top, while smaller side objectives, like earning stars for extra tips, stay tucked away until you want them. Suddenly, the player isn't guessing what to do. They're guided, but still free to tackle the kitchen chaos in their own style. And progress isn't just about checking boxes, it's about growth. That's where the skill tree comes in. It's not just stats and perks, it's identity. Am I a sneaky rogue, a lightning mage, a tank with a hammer? The tree makes those choices feel powerful and permanent. A best example is, you see the skill lists on the traditional tower defense games. Of course, just carrying items isn't satisfying until you let players mix and match. Welcome to the crafting system. It's the promise that junk isn't junk. Wood and stone are no longer clutter, they're potential. Sprinkle in some collectible recipes or blueprints, and suddenly your players aren't just crafting, they're discovering. To make sure they don't get lost, you drop in a mini-map. Some love it, some say it kills immersion, but it's the compass of the modern player. Without it, your world risks turning into a confusing maze. The best example is the ones that you often see in the car races. My personal favorite is Need for Speed, Most Wanted. And coming to the player, sometimes they get lost on who they are, while trying to process all those things at once. That's why you build a character sheet. It's the mirror of their journey, stats, equipment, resistances, where numbers translate into identity and power fantasy. Player needs dialogue. This is where your world speaks back. But dialogue isn't just text. It's the player shaping relationships, bending stories, and sometimes regretting what they said 3 hours later. Of course, those dialogue choices need a stage to shine. That's where cutscenes kick in, delivering emotion, drama, or pure spectacle in ways gameplay alone can't. Make them skippable or replayable because sometimes you want the drama, and sometimes you want to get back to slaying people, like the hero of GTA Vice City. But heroes don't live on story alone. They need gear. Enter the shop. Do you blow your gold on that shiny sword now, or save forever for the legendary one?
Okay, shop is one thing. But the player needs to have something to own that item in the shop, right? Those are collectibles. They're the optional ones, but also the one that makes the game addicting. Add little rewards for completing set skins, lore entries, tiny power-ups, and suddenly collecting isn't optional, it's irresistible. And finally, none of it matters without a save/load system. Progress is sacred. Whether it's a checkpoint, autosave, or quick save, players need to trust their time won't vanish. Or else they lose the motivation to go further. Alright, if the Garage Band stage is the starting point, then the Novice end, where you've built a functioning game with core systems, will make it feel like a real, playable adventure. But grab your seatbelts. The real game is just getting started. Yes, it starts with the sprite sheet. Instead of storing every animation frame as a separate image, you pack them into one big sheet. That's how Mario runs, jumps, and dies without your hard drive crying. Efficiency disguised as art. You need it so much, if you're actually making a professional game. Okay, let's say you're serious about making a professional game. The next fancy thing you need is a tile map. Tile maps let you build vast, complex levels out of tiny repeatable chunks like Lego for game worlds. It's cheaper, faster, and way cleaner than hand-drawing every pixel of terrain. Wait. But you need more than tiles, you need a level editor. This is the sandbox where designers sculpt worlds, drop enemies, and place secrets. The exact place where you can arrange your tile maps and feel like you're on an adventure. Tiled is a best example for this, since it has great flexibility. Once you reach here, you understand the tile map concept more clearly than any 2 hours lecture. Once a world exists, things inside it need rules. And that's where collision detection comes in. It's how the game knows your sword hit the enemy, or your character smacked into a wall. Without collisions, you'd fall through the floor forever. Of course, none of it matters if you can't actually see it. That's rendering, the act of taking all your math and data and turning it into pixels on the screen. The moment invisible code becomes visible game, but rendering alone doesn't keep things alive, you need a heartbeat. That's the game loop: update, render, repeat. 60 times per second, forever. It's the invisible drummer that keeps your game's rhythm. The problem is, not every drumbeat is equal. That's why you need delta time, a clever trick to make movements smooth no matter how speed your machine works. Think of delta time as the stopwatch between frames. Instead of moving your player by, say, 5 pixels every frame, you move them by speed times delta time. That way, whether your game runs at 30 FPS or 300 FPS, the movement still feels consistent. Without it, games would feel like chaos on fast PCs and sludge on old laptops. Next up, cameras. Players don't just need a world, they need a lens into it. Cameras pan, zoom, and track action, guiding attention without anyone realizing. In 2D, they scroll; in 3D, they are the player's eyes. The explanation may look simple, but actually putting the concept to work takes a lot of time. Maybe even few months. If you want, we can explain this concept in more depth with a special 3D game development concepts video. Comment below. Okay, here's the missing link: the physics engine. This is what breathes life into your game world, turning numbers into believable movement. It handles gravity, friction, momentum, and all the subtle rules of reality your game decides to obey or break. Without physics, games feel like cardboard cutouts. With physics, crates tumble down stairs, grenades bounce off walls, and ragdoll enemies flop in ways that make you laugh. Whether you're going for realism like Half-Life or stylized chaos like Goat Simulator, physics defines how your world feels. Of course, all this is meaningless if players can't interact. That's input handling. Every press of a key, flick of a joystick, or swipe on a screen must translate instantly into action. Alright, games are rarely just one endless level, you need scene management. It's how you load and unload levels, menus, and cutscenes without crashing the whole game. The all-rounder of your new game development. And finally, you wrap it all together with UI elements. Buttons, menus, overlays, unsexy, yes, but they're the glue between player and system. Without UI, nobody would even know how to start the game. Okay, let me just list out some important UI elements for you to note it down. Alright, with this, now let's move on to the next level, Proficient. Imagine 10 developers all touching the same codebase. You'd get chaos, overwrites, and broken builds every hour. Why? Because everyone might be changing the same file at the same time. One person fixes a bug, another adds a new feature, and suddenly someone's work erases someone else's. It's like 10 kids trying to draw on the same piece of paper at once, messy, frustrating, and nothing makes sense. This is where version control comes in. Think of it like a magical notebook that keeps track of every change a kid makes. You can always see who drew what, when they did it, and go back to a previous page if something gets messed up. The most popular version control is Git. With Git, each developer works on their own copy of the game's code. When they're done, they just commit their changes and merge them with the main code. And so, Git keeps everything organized and even warns you if two people change the same line, so you can fix it before chaos happens. You can make use of Git with the help of source control in Versus Code. It directly connects you to GitHub and let you have a private workspace there. Then there's resource management. Games aren't just code, they're textures, sounds, 3D models, particle effects and more. Managing them efficiently means your game runs smoothly instead of stuttering. This is where you learn that every megabyte matters. Minecraft is easily the best example for this, proving how smart resource use can easily outweigh flashy graphics. You know multiplayer games, right? They don't work magically. You need a networking model, the rules that decide how players' actions get synced across the internet. Some games use client-server models, where one machine, or a central server, is the authority, reducing cheating but requiring solid infrastructure. Others go for peer-to-peer models, where players connect directly, lighter on servers but heavier on trust. Choosing the right model can be the difference between buttery smooth matches or laggy chaos that makes players rage quit. And now, if you want to reach players everywhere, you need cross-platform builds. That means making your game run not just on PC, but on consoles, mobile, maybe even the web. Different hardware, different controls, same experience. It's the unglamorous but necessary bridge to bigger audiences. And once you have players, you'll need an economy system. Whether it's gold coins, upgrade tokens, or premium currency, economy is what ties gameplay to reward. Balance it right, and players feel powerful. You can also take reference from the famous RPGs like Brawl Stars, Stardew Valley etc. who does this job well. Okay, now imagine building a Lego castle and later finding some pieces are broken or missing. You don't throw it away, you fix it and maybe add a secret slide. That's what patching does for games. It fixes bugs, tweaks difficulty, and adds new content so the game keeps getting better without losing anything players already have. A good patch system keeps a game alive for years. But sometimes, you're not sure what players want, because the game released is fresh on market. That's where A/B testing steps in. Behind the scenes, different players quietly get different versions of the same feature. Take loot boxes, for example. One group of players might open a box and mostly see common items, with a rare reward appearing every now and then. Another group might get slightly better odds, with rares showing up more often. From the outside, players don't know anything's different. But on your end, the data starts rolling in. Does the group with higher rare drops play longer sessions because they're excited about rewards? Or does the group with fewer rares stick around because the challenge feels stronger? Maybe one group spends more money than the other. In the end, the numbers tell you which version actually keeps players hooked, and that's the one you push to everyone. And finally, there's progression system. This is what makes players come back. Leveling, unlocks, prestige loops, they transform your game from a one-and-done experience into a long-term relationship. We'll discuss about this more in a special video if possible. Alright. We've passed the proficient level and finally at the expert level. This is where game developers go from, I can make a game, to, I can bend the rules of how games are made. It starts with an IDE. Short form of Integration Development Environment. This is your cockpit, where code, debugging, and testing all happen. You know VS Code? Most of them just see it like a normal text editor, while it has more functions and shortcuts to help you shape code perfect. That's what you call a good IDE. And then comes graphics design. It's not just drawing pretty pictures, it's about crafting visual language. Visual communication, indeed. Players need to parse a scene in a blink. Color, composition, silhouette, all these determine how players read the game world in a split second. Style matters more than realism here. But you can't handcraft everything, every single rock, trees, or perhaps a dungeon. That's where procedural generation comes in. It's the game changer. Explaining this can be long, so for now just remember, it's like teaching the computer how to build those rocks and trees for you, so you don't have to place them one by one. You set the rules, and the computer fills in the world. It's an advanced concept, so not everyone touches it. Okay. To explain this, I know some of you know Unity. The way you make games there is practically ECS. Why? Because you break objects down into components like player, environment, movement, render, physics, assets, and stitch them all together, so it makes games scalable and lightning fast. That's what ECS is. Entity Component System. Instead of one big, player, object with every feature crammed in, you break everything down into modular parts, movement, physics, rendering, AI. Then you stitch them together into whatever you need. Once you get ECS, you start thinking about game objects like Lego bricks. And speaking of bricks, sound is one that's often ignored until you realize the whole wall collapses without it. Sound engineering is more than background music. It's how you know you're in a cavern instead of a hall. It's how you feel the difference between a pistol and a shotgun. It's how you sense danger before you see it. Silence itself. That's a sound design choice too. Ever played a platformer where you fall off the ledge and still manage to jump? That's called coyote time. It's not a bug, it's a feature. Humans aren't frame perfect, so games give us a grace window to make the controls feel tighter than we actually are. Speaking of timing, input buffering is another secret trick. Press jump a little too early, and the game holds onto that input for a few frames, so when the character is ready, the action still happens. But input buffering isn't just for jumps, it applies to attacks, dodges, and combos too. Ever queued up an attack in a fighting game just before the animation finishes? That's input buffering, making sure your moves land seamlessly. It's like the game is reading your mind, forgiving tiny missteps so your experience feels smooth and responsive.
Soon he will.
But big worlds demand optimization, which brings in LOD, level of detail. Why render a million polygons on a tree you can barely see? LOD swaps high detail for low detail on distant objects, making massive worlds actually run on real hardware. It's like as you move closer, objects gain detail seamlessly, giving the illusion that the world is endlessly rich. But a world isn't meant to just sit there looking pretty, it's built to be lived in. And living in that world are characters with their own logic. They can't just stand there like mannequins, they need to know when to idle, when to walk, when to attack, and when to drop dead. Enter the state machine. Characters don't just exist here, they live in states: idle, walking, attacking, dead. Each state defines how a character behaves, what animations play, and how it reacts to the player or the environment. Think of it as the invisible brain behind every character's move, keeping them real. And while all this is happening, you're not just guessing at what feels fun, you're looking at research data. Analytics tell you where players die too often, what weapons they ignore, how long they actually stick around. So, Fun isn't magic here, it's measurable data. But who said you can't have fun? That's the essence of life, nobody wanna miss. And speaking of measuring, sometimes players want to build with you. That's game mods. By exposing your tools, you turn fans into creators, and suddenly your game outlives its original design. Skyrim still thrives today thanks to mods. But that freedom comes with responsibility. Memory profiling is what keeps your game from turning into a RAM-hungry monster. Every memory leak, oversized asset, or lazy system piles up fast. Memory profiling finds those troublemakers early, so your game runs smooth instead of stuttering or crashing when players need it most. Ever played Skyrim with 200 mods loaded and watched it collapse under its own weight? Yeah, that's what happens without proper memory profiling. Because nothing kills immersion faster than a stutter or a crash right when the action peaks. And speaking of action, how does the game know when to start something? That's where trigger zones come in. Think of trigger zones as invisible landmines, except friendly. Step inside one, and something happens, a door opens, a cutscene starts, or enemies spawn. They're like stage cues in theater, silent, unseen, but essential for timing the show. Then there's object pooling, the trick to handling fast-paced chaos. Instead of creating and destroying bullets, enemies, or effects over and over, you recycle them. It's like a lending library for objects, and it makes your game run 10 times smoother. And finally, the cherry on top, ragdoll physics. That glorious, floppy chaos when a character gets knocked out, tumbles downstairs, or collides in unpredictable ways. But there's one rule for this club members, we can't talk about it. Alright guys. We have come to the end. I hope you understood the complexity behind game development. From tiny tricks like delta time to heavy hitters like memory profiling, every piece works together to make games feel alive and fun. Thanks for sticking around, and start making your first game. See you later.